So in one's complement, we move from left to right, 0 is converted to 1. We keep moving to the right and 1 is converted to 0 and we keep moving to the right till the time we find blank. And once we find blank, we stop and go to the final state QF. So such type of problems, they can ask for 3, 4 marks or 5 marks. So that is possible. Now in one of the problems, they could give is input is 0 raised to m, 1, 0 raised to n, and output should be 0 raised to p between the two blanks. And your p is nothing but m plus n. So number of zeros in the output is a combination of zeros above, and this one we are supposed to ignore. So what we do for this? So this is also quite a simple problem, similar to what we have done in one's complement. We are supposed to match the number of zeros in the output with the number of zeros in the input, which is a combination of 0 raised to m and 0 raised to n. So addition of those two zeros should be equal to the number of zeros here. There is one which is used as a separator. We need to take care of that. So we don't have to convert the zeros. So we keep the zeros as it is and keep on moving to the right. We don't have to do anything with that. But suppose we get 1. We convert it to 0 and we keep moving to the right. So what will happen? Suppose there are 2 zeros, 1 is there followed by 1 0. So you have converted this 1 also to 0. So you will have 4 zeros, but actually we want in the output 3 zeros. So what do? We'll go till the end, till the blank. We'll start coming back from there and the first 0 will be there, that will convert into blank. So 0 is kept as 0, 1 is converted to 0, and then we keep moving to the right. When we reach the blank on the right hand side, we keep blank as it is and start moving to the left now. We have changed the state to Q1. Now in Q1, when we are moving to the left and the first 0 that we encounter, that we will change to blank. So 0 will be changed to blank and we stop there and go to the final state QF. Are you getting this? So we are supposed to design a Turing machine which will give us, for a given input like this, it will give us the output 0 raised to p, where p is a combination of m and n. And then after that you can make the table for this. So yesterday also we had seen that from transition diagram you can draw the transition table. Now what it will have? It will have 0, it will have 1, and it will have blank. States will be Q0, which is the start state, Q1, and QF is the final state. Q0, when we get 0, we are in the same state as Q0. You keep 0 as it is and keep moving to the right. In Q0, when we get in Q0, when we get 1, we stay in the same state. 1 is converted to 0 and we keep moving to the right. And Q0, when we get blank, we change the state to Q1 and keep blank as it is and start moving to the left. In Q1, when we get 0, we convert it into blank and go to the final state, and we stay there. And QF is our final state. Are you getting this? Then next problem. Now we have found out one's complement of a binary number. Now let us find out two's complement of a binary number. So Turing machine to design two's complement. This was also asked in one of the exams. So the same number we'll take 0, 1, 0, 1, which we have used for one's complement. 1, 0, 1, 0 is one's complement of this particular number. What is two's complement for it? 1, 0, 1, 1. So this is two's complement for the given input. So if you observe the input, this one that is present is the same, and after that whatever zeros and ones or zeros are coming, that gets changed to 0 is converted to 1, 1 is converted to 0, and 0 is converted to 1. So till the time you find a 1 in your input, till that time we don't make any change. But after we find that 1, we change the zeros to 1 and 1 to 0. So this problem we have to do little carefully. That's why it was asked in the exam, because there is a possibility that you will make mistake here. So how to go about it? So what do? We start from Q0. We don't use the logic that we have used in one's complement. That whenever you're scanning from left to right, you make zeros as 1 and 1 as 0 and keep moving to the right. Like that we don't do. We keep moving to the right, keep 0 as it is, and keep moving to the right, keep 1 as it is, and keep moving to the right, and we move to the right blank symbol. So we move to the right blank symbol, keep blank as it is, and then we start moving to the left. Now we are in the state Q1. Now we had seen that 0, 1, 0, 1, till the time the first one comes, we are not making any changes. But afterwards, we get 0, 1, 0. That is converted to 1, 0, 1. So we can take one more example, 0, 1, 0, 1, double 0. One's complement of this will be 1, 0, 1, 0, 1, 1. And when you add 1 to this, how it will be? So 2's complement will be 1, 0, 1, 1. This will be again 0, 0. So if you observe these two, 0 is kept as it is till you get the first one. And when you get this one, after that, whatever value is, if 0 is there, you convert it to 1, 1 is there, you convert it to 0. So all the zeros will be kept as it is. And you keep moving to the left unless you find the first one. So once you find the first one, what do? We keep that one as it is, keep moving to the left, and then we just change the state to Q2. And in that Q2 state, what do? We convert 0 to 1, keep moving to the left, and 1 to 0 and keep moving to the left. This we continue till the time we reach the blank. So as soon as we reach blank, we go to the final state QF. Are you getting this? Now, there is one case which is not taken care of. If the input is 0, 0, 0, what is whose complement of this? First, we'll write 1's complement, which is 1, 1, 1. You add 1 to it, it will be 1, 0, 0, 0. Yes. Now, if we use this logic, what will happen? We'll scan the zeros and we'll go till the blank. We start moving from there to the left. We'll be moving here. So in Q1 only we'll get stuck. Now, how do you go to the final state? So if you observe here, this first blank is getting converted to 1. So from Q1, if you get a blank, what do? We convert that blank to 1 and then stop. So that is taken care by this particular transition. So this 2's complement of binary number is quite important for you to understand. All the cases we need to consider, then only you can solve this particular problem, which can be asked for 5 marks. Are you getting this? Pratik, are you getting this?
Yes.